Electronic circuits once involved miles of bulky wiring. Today they're reduced to compact units, like this computer circuit board. If there's a problem, simply pop in a new one and you're back in business. An electronic circuit board is a computer component which can produce spectacularly realistic scenes. Animating this particular three-dimensional graphic took 4 months of work by artists and programmers with the aid of a G400 graphic processor by Matrox. A printed circuit board can be compared to a building composed of fiberglass floors, copper passageways, and stairs that link the floors between them. Cards are assembled with two technologies, surface wiring and wiring through the card. The components are placed into the holes and soldered into place. A stencil is used to apply soldering paste onto the card. This paste will solder the surface components. Here they place the stencil into the printing unit. It is through these holes that the soldering paste will run. The machine spreads the soldering paste, which contains, among other elements, a tin lead alloy. The printing blades go into action. They spread the soldering paste on the stencil. This paste runs through the stencil holes and covers the metallic surfaces of the printed circuit board, which will establish the electric current. Here's the difference between an unprinted card and another printed one. The unprinted card surface is much more shiny. Now they're going to install the surface wiring elements. They are automatically positioned by this rapid placement machine. About 36,000 components are installed per hour, making it about 10 a second. This incredibly sophisticated machine is equipped with a viewing camera which verifies the alignment and dimensions of each part before installation. It unerringly positions the part at the exact spot. Another machine, slightly less precise than the previous one, installs parts where the space between two placement points is less than 0.5 millimeters. It can install 8,000 parts in 60 minutes. The card continues on its way toward the oven, which accomplishes an essential operation. Once the parts are secured, the card goes into a convection oven where the heat will solder the parts to the card. Different circuit connectors through the card are inserted into their respective holes. This operation requires great dexterity and is entirely done by hand. Then the metallic placement points need to be soldered to this card. The soldering of the circuit components through the card is done with a bath of molten tin lead alloy at a temperature of 240 degrees centigrade. Now everything is installed. They have to do an initial electrical test. The card is placed on a bed of electrified pegs. These pegs make contact with the card's connecting points, allowing them to check for short circuits or open circuits in the card. And then a final test, a computer-aided operating test to see if the card is functioning perfectly. This company fabricates 200 models of different circuit boards and produces about 4,000 cards each week. Cereal grains, water, fermentation, and distillation. These elements and processes transform into alcoholic beverages of distinction and tradition called spirits or liquor. The principle of distillation was known to ancient Romans who mastered the process. However, we still don't know the precise ingredients they were using. In the Middle Ages, stills produced the first alcohols from wine. The 7th century saw people making ethyl alcohol, and by the 15th century, the process was further refined, leading to the production of today's brandy, bourbon, cognac, and whiskey. Dried corn kernels is the main grain used in making spirits. Every day, 7 truckloads empty out 230 tons of it. This corn will produce the basic ingredient for spirits, such as whiskey, gin, creme de menthe, and amaretto. The kernels are stored in these 24-meter-high silos, which can hold up to 250 tons. This is the distillery control room. They're going to make a recipe that's 95% corn and produces neutral alcohol, to which they will add other grains for color and flavor. We see here the first step, the milling of the grain. Some 8 tons of corn flour and 18,000 liters of water are introduced into this autoclave and cooked with live steam for 90 minutes. Enzymes transform starch into sugar. Then they add the yeast, which converts sugar into alcohol. Fermentation lasts 60 hours at 38 degrees centigrade. The bubbling we see is created by the action of the yeasts. This cone removes the CO2, a natural byproduct of fermentation. Nearly 70 tons of CO2 are drawn off daily. Everything is monitored by computer. Some 24 hours have now passed since the start of fermentation. When this stage is ended, corn oil will have come to the surface and is clearly visible by its reddish color. The fermented mash has a 13% alcohol content. They now move on to the next step, distillation, which condenses the vapors of the mix. It's in this 3-column distillation system at a temperature of 85.5 degrees that the mash ferments and is distilled by live steam to separate the alcohol. All the distillation columns are continually monitored. During distillation, they dry the grains used in the recipe in this rotating drum. The resulting product is called draff, and it will be used to make animal feed. Distillation is now ended. To aromatize certain gins, they add dried lemon skins, some cinnamon, or coriander. Rum and whiskey will be aged in these 350,000 oak barrels. While aging, these spirits will lose about 3% of their alcohol content annually through evaporation. Also, the color gradually darkens. They're now ready to draw out the liquid from the barrels and put it into bottles, but first they have to verify the quality of the spirits. They compare the standard product with the new production. This test is highly important in order to assure the quality of the final product. Bottling begins. Here, 140 750 milliliter bottles of rum and spirits are filled every minute. Clean bottles circulate continually on the conveyor, leading them to the filling machine. Bottles are then filled automatically by this machine. It allows an exact quantity to flow into each bottle. The next step, a capper places caps on the bottles and crimps them onto the necks. Then the sealed and labeled bottles head for the packaging department. This other machine fills 120 bottles with 1.14 liters of Canadian whiskey every minute. In this distillery, some 20 different spirits are produced. With 34,000 tons of corn kernels, they produce 44,750,000 liter bottles of spirits annually.